This is a quick introduction to the Postgres migration tool called Metagration. And the idea of Metagration is that you can migrate Postgres with Postgres. You don't need an external tool written in any other languages, or how migrations are managed data like everything else. So typically database migrations are managed as code using some out of database tool. Um, this often boils down to source controlled files with ordered names like O1 this, O2 that, or date strings in the names so that they order lexicographically. The tool applies those files to a database, which just sees that tool as just another client. And then the tool may typically update a table in the database that contains the sort of current or last applied version. This can be hard to use with logical replication. You have to distribute these out-of-band changes, often in backwards compatible faces, and then carefully apply them at the right time. Because with logical replication, there may be changes that are applied on the publisher and then tuples that are in flight that have not yet been applied to the subscriber. And if you don't time the schema changes correctly or make them so that they're backwards compatible, you will have write conflicts that cause replication to stop. And then you have to mitigate that by sort of fixing up the broken replica and restarting replication so as to not lose data, or skip over the conflicting transactions, which causes you to lose data. So if a migration can and will fail with data loss, you also sort of have to make sure you take special precautions to support point-in-time recovery, like creating restore points on your own. Which leads to the question, if migrations are SQL changes to objects managed by SQL, why not just make those migrations objects themselves that are also managed by SQL? And that's the idea behind Metagration. And that is that Slonik, the Postgres elephant, can brush its own teeth. Now, this may not apply to real elephants, but the idea here is that the database can maintain itself, can do its own internal structural management of DDL changes. So that gets to manage migrations with Metagration. And the idea is that all database objects are managed data with SQL, including migration objects. These migration objects are dynamic procedures that can be written in any PL language, but PL/PG/SQL is kind of the natural one. And those procedures dynamically change the structure of the database with DDL. Migration objects and the act of applying them are decoupled. So you create migration objects in the database, and they may not be immediately applied. You may wait to apply them at the right point in time. And now these migrations, because they're just rows and tables, they can be logically replicated, then applied at the exact same point in the WAL timeline for the publisher and the subscriber. So that means that you don't get this sort of out of sync problem with tuples that are in flight. And Metagration integrates with point-in-time recovery. It will create what are called restore points, which are records in the WAL stream that have names. And you can, when you do point-in-time recovery, you can say recover to right before I did migration 5, and the database will recover right to that point. There's a pattern you can use with Metagration where if you happen to be a Postgres cloud database provider, you can publish official migrations that get published with PG Logical, and customers can subscribe to those updates, and they can either be applied automatically when you publish them, or they can queue up and then the customer could apply them on their own after they review them. And just sort of more detail on Metagration, it's less than 500 lines of commented readable SQL, PL/PG/SQL mostly. It has full PG tap coverage. And now the migrations themselves can be written in any PL language, so Python, JavaScript, PL Java. There's a whole bunch of them now. Metagration does still work with version control, so you can import and export a file of the Metagrations themselves, and then those imports and exports could be dropped in like a Docker entry point directory, and when you initialize a new Docker, it'll just automatically apply those migrations. And then that can sort of be your starting baseline if you're doing like development servers or forking off customer servers. All migrations get logged, including their start and end revisions, timestamps, and restore points. And it's not just a table with a single row telling you what the current version is, it gives you the entire migration history. that the migration order is enforced with constraint checking. So it uses sort of the full power of SQL to, you're not relying on these accidentally alphabetically ordered file names to apply order. And again, migrations can be replicated with PG Logical like any other data. And if you want to apply a migration across an entire replicated cluster, you can use PG Logical's replicate DDL command, and you can just say call migration.run, and it will run all migrations on all subscribers at the same point in the wall stream, so that you don't have this tuple in flight problem. And also, you could integrate it with a web front end. You could manage and migrate your database with text boxes and button clicks. It makes the migrations themselves managed data. So here's an example of creating and running a migration. It looks very similar to how you would just create a migration with many other tools. You have an up script. Here we're creating a table with one column. And you have a down script, which just drops that table. And then this is a pretty unique feature to Metagration, is that you can have a test script, and the test script integrates with the pgtap test runner and can use any pgtap functions, like this has table function comes from pgtap. So you can say call metagration.assert that the table foo exists, and have a little message. And this is a multi-line test script, so you can have multiple lines creating tables, altering columns, doing whatever you want, raising notices to the log so you can see what's going on. And then when you want to run, this new script function creates the migration, but it doesn't apply it yet. To apply it, you call metagration.run, and the runner will look at your current revision and the newest revision and apply forward through those revisions until you get to the last revision. And then if you want to, you can also call metagration.verify, which just runs these test scripts and doesn't actually change anything. It just goes through each revision and calls the test script, which in theory asserts that the effect that the migration had is still true. And that way you can know if sort of someone's been monkeying around dropping tables behind your back. And that's it. That's the introduction to Metagration. Thank you.